For my favorite brain part presentation, I want to talk to you about a group of cells that are often overlooked, but they play a crucial role in our brain's health, and those are microglia. First of all, what are microglia? Microglia are a type of immune cell that are unique to the central nervous system, which makes up the brain and the spinal cord. They compose up about 10% of the total cell population in the brain, and they're often referred to as the brain's immune system. You might be thinking, immune cells in the brain? Yes. Microglia act as the first line of defense against any harmful substances, infections, or injuries in the brain. They're constantly surveying their surroundings and quickly responding to any potential threats once molecules associated with damage are detected. Moreover, microglia are known to be highly dynamic and adaptable. They have the capability of traveling to the sites of damage and changing their shape, function, behavior in response to different stimuli, such as inflammation or injury, depending on what's best for the damage. They also can communicate with other cells in the brain, including neurons and other immune cells, through complex signaling pathways. While they play such an important role in our brain's health, they also play an even more significant role in memory and learning. Microglia are involved in our brain's development, learning, and memory. They play a crucial role in shaping the connections between nerve cells or neurons during brain development. They're also responsible for pruning or eliminating unnecessary connections and promoting the formation of new connections, which is something that's essential for proper brain wiring. If we can take a look at this chart, we see at birth the synaptic density is much less than at the age of 6 years old. But because of microglia, by the time we get to 14 years of age, a lot of those synapses have pruned and are no longer there and are no longer taking up unnecessary space. While the microglia play such an essential role in our health, there's also some negative implications in health too. When microglia become overactivated, they can also contribute to neuroinflammation, and this has been implicated in various neurological disorders such as Parkinson's, Alzheimer's, and particularly dementia and multiple sclerosis. And when there's an uncontrolled activation of microglia, it actually leads to digestion of healthy cells. And we can look over, and here's a brain with Alzheimer's disease on the severe side plus a normal brain, and we can see the overactivation has contributed to the shrinking of the brain. Additionally, microglia have been implicated in autism spectrum disorder. Patients with autism show an increased microglia activity and inflammation compared to those not diagnosed. And additionally, the inability to properly prune synapses results in this excess of inefficient synapses, which has been also attributed to autism. Studies with mice show less functional connectivity as a result of poor synaptic pruning, and those mice actually demonstrated autistic-like behavior compared to those with proper synaptic pruning. So in conclusion, microglia are just an incredible and indispensable part of our brain, and they serve as the brain's immune system, maintaining our brain health, supporting brain development, and modulating our brain function. Their complex and dynamic role in the brain is still being uncovered by researchers, and understanding microglia might hold promising insights for the treatment of neurological disorders in the future. Thank you.